prompted the next question. Russ, I want to come to you on this. So, because I think part of the value of this discussion is shining a light on use cases and applications that are possible with HAPS that are not possible with satellite, or less possible with satellite. Your company is involved, Jeff alluded to it, methane monitoring. Can you give us some color on some of the use cases you're looking to serve? And because I think that would be beneficial to a number of operators, and the trade-offs that are involved in that compared to if you were to try to do that with a satellite constellation.
Yeah, sure. So, I mean, this is Mobile World Congress, so I mean, starting a little bit with mobile applications and communication, I mean, we know that there's coverage in a lot of parts of the earth, but I think if you look at things that are regional, seasonal, underserved, infrastructure disadvantaged, that's what we've traditionally talked about with HAPS. And we're starting to see that, right? We're starting to actively work to employ that. So we have a program going with the U.S. Forest Service right now, and it's an example where they're looking to enable direct-to-device connectivity for wildland firefighters. So during fire seasons in the U.S. in the mountains, you know, they don't have good connectivity there. And you can set up SATCOM, and LEO is a powerful tool, but if you're a firefighter who's literally out there digging trenches in the forest, you may not have the time, energy, or space to set up a satellite dish. So if we can enable or empower that person to have a connection directly on their phone, so that's what we're doing. We're flying through the HAPS, the balloon in our case. You're getting satellite connectivity down to the HAPS platform, and then direct LTE connectivity to the phone. And then doing that at a data rate that enables more than just occasional messages. You know, we mentioned direct-to-device from LEO, you know, but the bandwidth is limited. Again, it's that laws of physics thing. We can provide enough of a link that they can make a phone call or, for example, download. So one of the things we're doing is flying an infrared camera sensor. They can get a real-time mapping from, you know, 20 kilometers up of where that fire is at. And if you're on the ground with limited communication trying to fight that fire, that's really important information, right? So that's a good example. Jeff brought up the methane monitoring. So we just concluded a project, we're ongoing, I guess. We just concluded a flight in partnership with a company called Scepter Air, who has a data delivery platform for hyperspectral imagery. And one of the things they're doing with that is on the end customer is ExxonMobil, which is a large oil and gas company. So in Western Texas, in the United States, they have a large area of infrastructure with lots of wellheads and things where they're extracting those resources. And they need to be able to detect and quickly fix leaks. You know, methane, we just had the COP conference. That's one of the key drivers for global warming. And so they're trying to figure out how they can do that. So with satellites, you know, first off, you have to have a satellite with a specialized sensor for detecting that. Now, you can do that, but you're probably not going to put up a whole constellation of LEO satellites with that kind of sensor. That's pretty expensive for what is needed. There are some satellites out there that can do that. Most of them, since there's only one or two satellites, they might be making a pass over that area once or twice a day. So the problem you have in the methane situation is you have what you call intermittent leaks, right? Where maybe some valve or something on a piece of equipment is failing and there's occasionally a discharge. Those discharges can add up to a significant amount of methane over the course of a day, but they're not happening all the time. So if you don't happen to have that satellite come over at that exact moment when that leak is occurring, you're not going to detect it. So the nice thing about using a HAPS platform is it can be persistent on station regionally. You can put a few of these aircraft or balloons or whatever over that area with the right sensor and get that real-time coverage. So there's no reason you can't combine those things, like with that Forest Service example where you have communications and imaging. Once we get the platforms to the maturity we're flying, then we're proving that it'll work. You can build out a payload stack that has multiple modes and solve several problems at once. So those are just some examples.
Yep.
If I can add a couple of points just on the back of that. So obviously, one of the things we're seeing was we've spoken about mobile connectivity from the stratosphere, and that's a great example of what Russ has just shared. But speaking with mobile operators all around the world, what we have seen is there's primarily four types of use case that the mobile operators are really looking in to serve. One that is coming up more and more as the world's environment changes is disaster recovery, both for the first responders, but also for the communities that are unconnected during that horrible event, whatever that may be. The second one is obviously rural coverage and infill, being able to provide white spot or coverage that, you know, it's just very difficult to get to either because of the terrain or because of the costs involved in building out or low populations. And then the third one is platform mobility. So I spoke about that on Monday in a session in the smart mobility, which is because of the low latency nature that HAPS can offer, things like drones, eVTOLs, other aircraft, autonomous vehicles can all benefit from this type of connectivity. It can be very targeted. It can even be a 5G private environment. And then the last one is maritime connectivity. So being able to manage and monitor some of the shipping vessels. Obviously, border security and border patrol is very, very high on any nation with a coast. So just to add a bit more flavor about the connectivity applications that we can serve.
And I'm glad you brought up the emergency response scenario there. That has generated a lot of discussion this week, and I'm sure we're all aware of a number of deployments in place in various parts of the world to serve that. Just practically speaking, and maybe Greg, I can come to you on this. Like, let's just take that example of let's say there is a hurricane that wreaks disaster in a given state in the United States or a province somewhere or a country or whatever. How would we envisage a HAPS setup being implemented to serve that use case? Is it scrambled in quick order? HAPS vehicles sent up to that given area. How can we how would a government or a telco think about the implementation model for that?
Sure, great question, and we're doing some work on that right now and some modeling. Probably two scenarios. If you have advance notice of inclement weather situations like that, smartest thing would be to get a HAPS platform in the Stratosphere, which is normally above any weather conditions that would affect. In that instance, if you had a catastrophic storm that came in and wiped out your infrastructure, part of your infrastructure that includes towers and power and diesel backup generators, et cetera, there'd be an immediate handoff. So theoretically, there wouldn't be any downtime of communications to that given area that's on the ground. The other way would be if there's events that are man-made. Right after that event happens, you could send up a stratospheric platform also into that area. You think about the time frame to go from airport to station keep. In our scenario is about 3.5 hours from that standpoint. So, it's pretty quick. And I think it all comes back to, if you think about, and you see pictures of earthquakes or disasters that had happened in the past, a lot of it is about, it's after the event, and, communications and food and fuel and things like that take days and days to get into these areas. If you have that communications infrastructure that could be either there pre-positioned or within hours, I think that's a game changer for these applications.
And if I could
please
jump in on this, this disaster recovery point, this is approaching ancient history now, so apologies for that. But it was 2018 when Hurricane Maria took out a significant percentage of the islands in the Caribbean, including the southeast United States. Loon was in the process of doing testing in South America at the time. So there was ground infrastructure in place. But within a matter of days after Hurricane Maria took out the entire island of Puerto Rico, Loon, in partnership with AT&T and T-Mobile, lit the island back up in 3 days. And cell phone service was restored across the entire island of Puerto Rico in 3 days. And one of the fun little stories that came out of that is there were families that lived in the particularly mountainous, remote areas of Puerto Rico that never had cellular coverage. And all of a sudden, they have cellular coverage in their homes in areas where they never had it before. Now, those mobile network operators restored traditional service in about six weeks' time, and we flew our balloons back out of there. But that, I think, was a nice example of the capabilities that we're talking about. And I think it was Greg that mentioned, to the extent that whether it be earthquakes in Japan or the Caribbean and those types of weather conditions, to the extent that you can at least statistically anticipate where you might have it, a little bit of relatively low-cost provisioning to allow a HAPS fleet to come in and to provide service when it's needed. That's a pretty cost-effective and pretty high-performance disaster planning type of investment that countries and governments should be considering.